Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad FAKHRUL AIZAT bin Mohamad. So today we would like to present for our group assignment for power quality subject BEF 44803. So for our project title is about voltage sag protection for grid connected solar system. Okay, this is our team members. First one, Mohamad HAZWAN bin Abu Bakar. Second, Syahzani Arifah binti Hasan. And then Mohamad FAHMI bin NORRAWAI. And me, Mohamad FAKHRUL AIZAT bin Mohamad. And last one, Mohamad Adam Harith bin Mohamad Adam. So for the introduction, renewable energy is energy that is clean and created through a continuous replenishment process. Renewable energy source include solar energy, wind energy, hydroelectric energy, and geothermal energy. So, for this project assignment, we are required to focus on the solar energy. So, solar power is solar energy in electrical or thermal energy produced by the sun. Solar energy is collected in many ways, most often via solar panels, which transform the sun's rays into useful power. So, as we know, which is in the solar energy can produce the power energy. So nowadays, when the technology is more advanced, so we can also have the problems on the technology. So each of the problem as an engineer, we must troubleshoot it. So for this group assignment, for this project, we will focus about the voltage sag on the photovoltaic system. So voltage sags are erratic and sporadic. Sag begins with when the voltage falls below 90% of its nominal value and ceases when voltage rise above 90%. Voltage sag duration is measured in milliseconds up to 1 minute. So the majority of the voltage sag has a duration of less than 1 second and a residual voltage greater up to 40% of the rated value. So as we can see at the figure above shows that one of the example for the voltage sag problems. So in the middle of the sinusoidal, the voltage is fall down around 90% of its nominal value. Okay, then for the problem statement, the main worry with the voltage sag is the effect it can have on sensitive equipment including speed drive motor, drive control, motor starting contractors, programmable logic controllers, robotic controller power supply, and control relays. The equipment will fail or shut down as a result of it. So as well as high current imbalance that could blow the fuse or trip the breakers. Furthermore, the repercussions of these effects can be quite costly for consumers, ranging from minor quality differences to production downtime and equipment damage. So for the objective, this project is to examine the effect of a photovoltaic plant on voltage sag performance. And then we also want to investigate the influence of power factor fluctuation during PV plant integration into power system network. So for the scope, this project is determine the nonlinear load and lower the voltage sags using MATLAB, and then install a filter to remove prevent voltage sags from entering the system using MATLAB. And then we also will modify the system frequency response to avoid harmful interaction with voltage using MATLAB. So for the next presentation, I will pass to my friend.
Yeah, Assalamualaikum. My name is Mohamad Zulhazwan bin Abu Bakar. So I will explain the literature review for our project. So power quality may be defined as the voltage characteristic that influence the consumer's oversensitive equipment. It can be defined as any power problem expressed in voltage, current, or frequency variation that result in the failure or breakdown of consumer equipment. Poor power quality has the greatest impact on the industrial sector, resulting not only in greater energy and output interruption but also in a higher energy price. Good power quality may offer substantial advantage to the industrial sector, including lower electrical and thermal stress and cheaper expenses. Power quality problem on PV system. The undesirable effect of solar system in a high integration level has pushed energy stakeholders to limit such penetration in order to prevent this negative impact. The problem of power quality is a significant challenge in terms of solar penetration. There are major problems that must be addressed when comparing PV system to other renewable technologies. Overloading of either harmonic pollution, high investment cost, poor efficiency, and low dependability are all problems that may have a detrimental impact on the PV system. Disturbance and effect of power quality. Poor power quality may have a negative impact on huge industry complex, data center, essential medical equipment, as well as small company and even homes. It may slow down production industry, damage sensitive equipment, and have an impact on productivity and expense. Example of disable is voltage sag due to issue at a distant location such as missing memories, errors, small display screen, and equipment shutdown. Next, random data mistake and continuous distortion of normal voltage are produced by nonlinear load and system resonance. Voltage speaker and or over voltage also power quality disruption. Dynamic voltage restorer (DVR). The DVR monitors and adjusts for sags in the voltage of the alternating current power supply, shielding the loads from these power dependability problems. The performance of DVR detects that injects the desired voltage and mitigate any unbalanced voltage. The DVR is responsible for supplying the voltage differential between lines during voltage sag and maintaining the nominal voltage value at the load side.
Assalamualaikum. My name is Mohamad Harith bin Muhammad ADNAN. Okay, for this project, I will explain about the methodology part and the conclusion part. Okay, for the methodology, as we can see in the flowchart, we start the program and we enter the simulink in the command window using in the MATLAB software, and then we add block to the model, and then we move the analysis block, draw signal lines between blocks, set the parameter, then run the simulation, output current and voltage. We can see if yes, then analyze the output waveform. If no, we run again the simulation. Then it is the end of the project. For the methodology, the DVR detects the voltage surge in bus bar 2, that is VLOAD, and the controller's rate feedback VLOAD creates a PWM signal from the system. The dynamic voltage restorer, that is DVR, which is serially linked to the network through the interactive transformer, changes voltage at loading terminals to compensate for PQ problems, for example sag, cell, harmonics and voltage imbalance.
Hi, Assalamualaikum. My name is Syahzani Arifah with Hasan. My metric number is AE170076. So today I will present the simulation part for this project by using the MATLAB simulink. So first of all, we know that there are various types of power quality issues that can occur within the PV system. Therefore, in this project, the power quality issue that has been chosen by our group is the voltage sag. Voltage sag is when there is a short duration or short period of time drop in the voltage value. There are two main factors that can cause voltage sag, which are the induction motor as well as the fault in the system. So as you can see here, this is the design for our project. The system that I use in this project is three-phase power system. This is the source, the three-phase source, and we will be connected to the winding transformer winding that is in the delta Y configuration. And there are two buses over here, bus number 1 and bus number 2. So bus number 1 is to indicate the voltage ABC from the transformer and as well as current ABC from the transformer. The VRMS is 400, and for the bus number 2 is to indicate the voltage and the current value in the load. The VRMS also 400. Between these two buses, there are three-phase breaker, which initially in a closed condition. And then we will have the three-phase connected load. The VRMS is 400 and the frequency is 50. And then we will have the three-phase fault over here. This block is used to create the voltage sag in the system by adjusting the switching time over here when the fault will occur, which we will be discussed later. And then the mitigation technique to compensate the voltage sag is by using the DVR, dynamic voltage restorer. This is the system. When we click, we will have the controller subsystem as well as other components. First, we will look at the controller. This is the PI controller. So this is the PI controller. And the PI controller is to convert the ABC into the D and Q coordinate. This is the PI, T and PIQ. So the PI controller is to control the value of D and Q so that there will be low errors, and as well as the accuracy will be more accurate. The output from the PI controller, which is over here, it will give pulses to the gate, which the voltage received from the controller will be used to inject the injection transformer over here that will mitigate the voltage sag that will be discussed later on. Then we move on to the converter. This is the IGBT converter, two-level converter. This is connected to the DC voltage source as well as the R element. And then we connect the converter to the three-phase breaker, which initially open condition, as well as the RL and RC component. So the purpose of connecting these RL and RC is they act as a filter to reduce the switching harmonics in the system. After they filter the voltage received from the source, which is over here, they will supply the voltage to the injection transformer. This is the injection transformer that is used to compensate the voltage. Now we will proceed to the simulation. The runtime of this system is 0.5. And first of all, I will disconnect all of these faults to compare the before and after mitigation of voltage sag. Let's run the system. So this is the result from the simulation. There are three voltages. The first one is the voltage ABC, which is from the transformer winding. And the second one is the voltage in the load. And the third one is the injected voltage during the injection mode. So as you can see, since there is no fault occur in the system, the sinusoidal wave should not be any problems because the fault is not there. And the V has run smoothly so far. And I will run this system for as long as until 0.5 seconds. Almost done. Alright, so this is the result. And next one, we will connect all these faults to the system, and we will see how it changes the result. And then we will run the system. So while we read the simulation, I will explain about the block of previous fault. So this block is used to create the problem in the system. And then I will adjust the switching time, which is I will adjust the time when the fault should occur in the system, which in this case I will set to from 0.2 second until 0.2 second. So in the scope here, during 0.2, which is here, until 0.3, it should be the fault occur. So as you can see here, this is the voltage sag for the system. The first one is the voltage sag. Then the third one is the injection voltage, which the DVR, the dynamic voltage restorer, the voltage will the voltage from the controller will give pulses to the gate, and then the gate will supply the voltage to the injection transformer whenever the fault occur. So you can see the result here. So this is the result. This is the voltage from the transformer, and this is when the injection voltage occur because it wants to balance the unbalanced voltage. So this is considered the unbalanced voltage. So I think that's all for me. I hope you clearly understand with the videos and simulation, and thank you for watching.
Assalamualaikum, my name is Mohamad FAHMI bin NORRAWAI, and now I would like to explain about the result and discussion for our project. What I would like to explain in this part is three-phase distribution system, and then three-phase distribution system with dynamic voltage restorer, or what we call DVR, and the discussion and analysis by each graph. So in this section, we will discuss regarding the analysis of power quality issues that involve in the circuit, which is voltage sags. The result will be compared from before and after the mitigation of voltage sags, and also will be explained accordingly. So next we go to the first one, that is three-phase distribution system. The three-phase distribution system is run for 0.5 second under 50 Hz operating frequency. Fault is occurring from 0.2 second to 0.3 seconds. Voltage sags happen when presence of faults. So next we go to the first figure. That is, the first figure is about fault focus at transmission line of three-phase system. In figure 1, what we can see is this is the simulation using Simulink MATLAB, and when fault is present at three-phase system transmission line. So next we go to figure 4.2. In figure 4.2, the graph shows that the load voltage against time when fault occur from 0.2 seconds to 0.3 seconds. That is voltage sags happen here when present of fault, whenever a fault occurs on either the utility transmission or distribution system that supply the facility, and the maximum load voltage is 1. Okay, So next we go to the second point that I would like to explain is three-phase distribution system with dynamic voltage restorer DVR. So this is the mitigation that we choose to the circuit. A dynamic voltage restorer DVR is implemented as a mitigation to overcome voltage sags of three-phase system. So next we go to the figure 4.3, which is three-phase system with DVR. The DVR implementation displays three-phase distribution system in this figure. The DVR will detect the voltage sags in bus bar 2 VLOAD, and the read feedback of the controller VLOAD generate PWM signals from the system. The dynamic voltage DVR, which is serial connected to the network through the interactive transformer, adjust voltage from several PQ issues like a sag, swell, harmonic, and voltage imbalance at loading terminals. The fundamental concept of the DVR is that the voltage of the requested size and frequency can be restored even if the source voltage is imbalanced or distorted to the proper waveform amplitude. So next, figure 4.4, which is the inner circuit of dynamic restorer DVR. So this is with the inner circuit that we got from the DVR. Okay, next is the voltage graph PU of the in this figure is the voltage against time graph of bus bar, load, and injection voltage. Okay, graph in this graph figure 4.5 indicates that 0.2 second to 0.3 second is a fault. In reading VABC, the V injection graph is created and then find out that the system injects V into an original system in order to achieve a perfect V load if there is a voltage sags. So that's all from me. Thank you.
Okay, for now I will explain the conclusion of this project. As a result, the power quality issue of voltage reduction is being represented. MATLAB program for simulating voltage stage one of power quality disturbance. The plot and transitory outcome are displayed. Then the fault occurs causing voltage sag to happen on either the utility transmission or distribution system. As a result, a dynamic voltage restorer DVR was employed, mitigating device designed to detect the sag occur and read feedback from the controller. It then generates PWM signal from the system. It is critical to resolve the issue with the power quality electrical system in order to produce better and smoother electrical flow. Finally, this team completed this project successfully. Each group member plays an important role to complete this project. Then the collaboration of each member is his strength to simulate the MATLAB program and the mitigation part overcome the voltage sag problem.